Here we go. First lesson, topic 5. Topic 5. And this is actually technically not lesson 1. It is lesson 0. So we're doing some foundation building before we jump into the first lesson of this unit. We have an essential question that's already given us. How do I identify the slope and y-intercept of a linear equation? Great. So what we're going to be doing is taking linear equations. We're taking equations that are linear and turning them into slope-intercept form here. So let's just go back and remind ourselves some definitions of these. Like, what is slope? So slope is a measure of the steepness of a line. When I say that, we know that it is a ratio or comparison of how something changes vertically to how it changes horizontally. A ratio of the horizontal to the vertical. We also know that in a couple different ways, right? One is to say that we have rise over 1. How do we change vertically over how do we change horizontally? And lastly, we can put in the idea that, at a higher level, we can say that it is a change of y, delta y over delta x. Now, we have a specific variable for slope, and that is m. So when we look at the general formula here for slope-intercept form, we know that that m right there is the slope. It is not the m and the x, it is just the m. Now, at any time, if I'm going too fast, please pause the video. That's totally fine. Let's look at the example here that we have with this picture. So when we see this says our equation right here. There's our slope. Whoa, there's no number there. Well, you're right. But we know that there's a coefficient of 1 in front of every x. So this just says that the coefficient of x here is -1. So that's the slope. That's a -1 over 1, which means what we should see in the line is down 1, right 1. Down 1, right 1. And that should be varied at any part of the line. So if I was to go from this point to this point, we should be able to get down 1, right 1, the same. 1, 2, 3, 4, 5, 6. I've gone 6 down. 1, 2, 3, 4, 5, 6. I've gone 6 positively, which gives us a ratio of rise to run of -6 over +6, which simplifies to -1 over 1. That worked out. It should work out. It's a straight line. So it's the slope no matter where it is, where we check it, because the line's not changing in any place. Next, we've got y-intercept. Y-intercept is where the line crosses the y-axis. Now, some of us still are kind of looking around for where this is. So in our slope-intercept formula here, it is the b. That's our y-intercept. So whatever value there is our y-intercept. And it could be positive or negative. We write plus because we don't want the opposite of b. We want b. But b can be negative. So at this point, let's look over here. We got 2 lines. We've got line 2 and line 1. Put a dot where the y-intercepts are for each of those lines. Pause the video. Go ahead and do it. Now that you've unpaused, the thing that I was reminding most people about was like, this is the y-axis. So when I say that's the y-axis, then I've got this intersection right here, and I've got this intersection right here. Now, if I state what numbers those are, if you haven't done that already, what numbers are represented there? So line 2's y-intercept is +3. Line 1's y-intercept is -5, because it's 1 above -6. Going down to the definition for linear equation, we talk about a linear equation. What we're talking about is an equation in, and this is important, 2 variables. Now, generally we use x and y, but it doesn't have to be x and y. It kind of helps us with x and y because we know that those are inputs and outputs. Not only do we have 2 variables, but then when we take this, we graph it, it's going to graph as a line. Now, another pause moment coming up. Make up 2 linear equations here in slope-intercept form. Pause your video. Now that you've unpaused your video, you should have something like y equals 2x plus 1, or y equals 1/3 x minus 100, or y equals negative 2.5x plus 1,000. Something that has a y and an x, and also a coefficient of x for the slope, and a constant for our y-intercept. Now on our last line, the slope-intercept form of a linear equation is just the definition of the slope-intercept form. So we don't need to necessarily write here because I asked you to do that before, so I'm just going to draw a little arrow to connect those two. Here's my slope-intercept form equation examples. Here they are here too. Great, flip it over. Let's look at the next page. The next page, page 4. Page 4 in this note packet. I don't know if future note packets, maybe it's in a different place. Okay, top half here, all I want you to do, pause the video, fill in your slopes and y-intercepts in the top half, and then come back and check to see if you have it. I'm going to fill it in right now. So you have unpaused to get 2 over 1. Does it have to be a fraction? No. It doesn't have to be a fraction, but I wrote it as a fraction just to remind myself that it is a vertical change over a horizontal change. Change of y over change of x. And then positive 1 here. Negative 3 over 1, positive 15. Positive 2 over 3, negative 6. Negative 1 over 9, negative 7. 2 over 3, positive 22. Negative 1 over 9, positive 1. 2 over 1, positive 1. 9 over 1, negative 17. Check and see how you did. As always, when you're doing this, if you have a problem, you run into an issue that you're like, I don't know why I did that or how I got that, please feel free to ask me. It's totally fine. Okay, last section. So this is the 8th grade portion of this. This is the thing we need to be able to do. Is take regular equations and turn them into slope-intercept form. So when we do this, the first thing we're going to start with is just check for slope-intercept form. Are we in slope-intercept form? Now, when we do that, if the answer is yes, we're going to do nothing. We're good to go. We're going to say, hooray! No worries, we can go on with our lives without having to do any math. If the answer is no, though, what we need to do is we need to solve for y. And what that means is we need to be able to write the equation so that says y equals something. Right? Y equals something. Now, really critical in this is understanding what the coefficient of y is here in slope-intercept form. What we really have to make sure that happens is that we need a coefficient of 1 for y. That y has to be a coefficient of 1. If we can get it to that, y equals something, then we can easily identify slope and y-intercept for any equation. Let's do these examples. Is this in slope-intercept form? Slope-intercept form, of course, looks like this. Y equals mx plus b. No, it's not in slope-intercept form. Of course it isn't. So what we need to do is move terms away from y so that we can get y by itself. So eventually what we want this to read is y equals something. So in this case, don't think arithmetically. Don't think like mathy. Think algebraically here. So I'm just subtracting 8x from this side to make this 0, which is going to leave me 4y. Now these are unlike terms here. Unlike. And because they're unlike, that means I can't combine them. So this just ends up being negative 8x plus 24. Why is it plus 24? Because this is plus 24. No sign there means positive 24. Do I have a coefficient of 1 for y? I do not, which means I need to make it into 1. The only number that I can divide 4 by, oh, that's right, let's not forget, this is multiplication. 4y is multiplication, and to undo multiplication, we need to divide. So we're going to divide by 4. No other number will give us 1y at the end. So 4 divided by 4 gives us 1. But if I divide this by 4, it is mandatory that every term gets divided by 4. Negative 8 divided by 4 is negative 2x. Positive 24 divided by positive 4 is 6. Are we in slope-intercept form? Absolutely. I know the slope of this line up here, which is this, has a slope of -2, down 2, right 1, and a y-intercept of +6. So we're going to go through the y-axis above the origin. Let's look at the middle one. Let's move that x term away because it's over here with the y. We don't want it there. Leaving us 9y equals 3x plus 36. We need 1y, not 9y. Uh-oh, what's going on here? Well, I can just write it as the fraction. 3/9 x plus how many 9s in 36? 4. Okay, good. Are we done? And the problem is, well, the answer is no. We always want to simplify our fractions. Always. There's never a time when we don't. So we've got to simplify that, which means we're going to divide both of these by a common factor, which is 3. So our real slope, these are the same slopes, but we want it in a simplified form, is 1/3 x plus 4. Now, when we simplify that fraction, nothing else happens in the equation. We're just making this fraction into simpler terms. Same fraction, same value, equivalent fractions, just in a simpler form here. Okay, one more. Ooh, we've got 2 to move. All right, so let's take 32 from both sides, which leaves me 2x minus 8y equals -32. Now I'm going to take 2x from both sides, which leaves me -8y equals -2x minus 32. Now, don't overthink here. We need 1y, so we're going to divide by -8, divide by -8, divide by -8. -8 divided by -8 is positive y. Now I've got a negative divided by a negative, so this is just going to be -2 over -8x. How many -8s in -32? There are 4. We've got to simplify this fraction. Y equals, a negative divided by a negative is a positive. Divide them both by 2. Technically, we're dividing both by -2, which should give us 1/4 x. And then +4 is just along for the ride. Y equals 1/4 x plus 4. Now we've got a slope, up 1, right 4. We've got a y-intercept, 4 steps above the origin. All right. If you have questions, please feel free to ask me. Ask anybody in the math department. Everybody's really helpful. We're a nice group of people. Good luck!